Mechanism of aeolian processes is abrasion. So to abrade is to remove um, through rubbing. And in this case, what we're doing is we're kind of sandblasting. What has happened is that the wind has been able to pick up some volume of particles. They may have been picked up from a deflation bowl, and they are suspended in the atmosphere, either suspended because they are very, very small and can reach a number of meters above the surface of the earth, or they are saltated. And we'll talk about saltation in a few minutes here. Um, with that, all of those little pieces that have some time or residency in the atmosphere are able to be struck by an immovable object. So when they do so, they slowly chip away at a structure, another rock feature, a building, a statue, begins to become polished or eroded by that suspending material. How that polishing takes place and how effective it is dependent on how hard a rock is being blasted. So if the rock that is being influenced by the suspended particles is softer than the suspended particles, then that rock will have a tendency to erode quite readily. The softer the rock, the faster the erosion rate will be. The other function is velocity. So if we've got a high volume velocity environment with a lot of material being transported, a softer material can abrade harder material, but it's going to take a whole lot more effort in order to do so, and therefore a lot more time. Because wind doesn't have a lot of density to it, the abrasion rate is usually restricted to 6 feet above the surface of the earth or lower. That's not an absolute. During significant desert storms and sandstorms, the column of air that's carrying particle matter can reach several tens of feet into the atmosphere. But those generally are less common and therefore have less propensity to do any significant volume of erosion as a result. The aeolian erosion process that produces features like this ventifact here. So in desert environments or dry land environments, there's usually one, maybe two primarily seasonal wind directions. Those wind directions are going to dictate the shape of the feature that's being polished by the wind's abrasion axe. So first of all, I've got to say that particles only get moved a very short distance at a time. They may only travel a number of feet, but then they get picked up again, right? So it may look like a continuous movement of a total volume, but you're seeing a rotation within that where things are being picked up and dropped and picked up and dropped and picked up and dropped as the wind is pushing through. All right, so I need you to keep that in mind. More often than not, the wind will pick something up, and then even though the wind is still blowing, that's particle likely isn't going to travel much further than the distance that it was carried initially. All right, so these features have a windward side, which is the side that erosion takes place on. So we've got particles and wind on this side. We are blasting this side so you can see the angle of erosion which has taken place in this feature. It actually has an elongated form as well. So if you were to look at this from overhead, it's kind of a teardrop shape with the narrow part of the teardrop here and then a bulb on this side. So we're polishing it around, and eventually we're going to continue to polish this so there's very little of it left. The windward side is pitted and grooved, so we can tell which direction the wind is from, even if the wind doesn't happen to be blowing when we're looking at a feature, by those two characteristics. The direction of elongation of the feature and which side has got pitting that has occurred upon it.